in class earlier, what I was saying was the metals, group 1, 2, and 3, will have a positive charge, and the ions, the nonmetals, will have a negative charge, which are on the right hand side of the periodic table. Now, why? Is because of this guy, how the periodic table is arranged. Now, let's get a good pen out. Blue. So, the valence electrons over here, the valency is 1 because it's in group 1, the outer electron is 1. And remember the octet rule where all atoms are trying to have an 8 electron configuration on the outermost shell. Inside doesn't, we don't really care. On the outside, 8, right? The octet rule. They're trying to go for 8. That's why noble gases do not react at all, because they're all fully filled outer shells. They're all 8. They're in group 8 as well. Now, another thing one of the students raised was it says group 13, 14, 15, 16, which is the same thing. They're just calling it different now. They added these into groups. So we still ignore them. Nothing's changed aside from 3 is now 13, 4 is now 14, so on and so forth. So that's not a big deal. But we're focusing on group 1, group 2, group 3, 4, 5, 6, 7. Ignore group 8 and let's apply that the charges which we saw earlier. Now for group 1, it's very easy to lose 1 electron and get a inner complete of 8, right? Like it doesn't matter. So it's way easier for lithium to lose an electron and satisfy the octet rule. So with that logic, and by easy I mean it's easier to, the other thing what lithium can do is either lose 1 or gain 7, and that's way harder to do. It doesn't want, like 7, where will it find 7 electrons? So it ends up losing 1, and it's more favorable like that. Okay. So with that logic, lithium, well that's, I don't like that. I should practice this earlier, right? This is +1, +1, +2, and +3. Because each of these, with the charges on them, this has 2 electrons in its outer shell. It would rather lose 2 than gain 6. It's easier. Same with boron. It can, what do you call it? Lose 3 rather than gain 5 to fill its outer octet. So इनके जब भी ions बनते हैं, they'll have these charges corresponding to their group number. It's easier to remember it that way. But on the other side, you have group 7, group 6, and group 5, which are almost full, right? These guys are almost full. So they do something different. Instead of losing electrons, they gain electrons and make their current shell, their outer shell, complete with 8 electrons. So for fluorine, for example, or any group 7, because they have 7 outer shells, they'll gain 1 and it'll be -1 charge if they form ions once they gain that electron. For oxygen or any group 6 element, it'll be -2 and -3. Okay, this is the logic. For group 4, you don't really care too much, but I like to see it as like a point of symmetry between these guys and these guys, right? And so that's one part. The other part is they're trying to balance charges. Let's go there. Let's take a look at if you had sodium chloride. Now you know it's NaCl, but why is it NaCl? Let's take sodium and chlorine. They form a bond together. Now sodium, if you check the periodic table, is in group 1. This is in group 7 or 17. So their corresponding charges are +1 when they form ions and -1 for chlorine. Okay. So if on the right hand side I write that down again, it's NaCl plus and minus. Now how they bond is they're trying to balance the charges. That's the next step. The next step is you try to balance the charges. There's 1 positive charge here for, that's an ugly green, and 1 negative charge here for the chlorine. Okay? So if you put them together, they'll just balance out. +1 -1 is 0, right? So they balance out. So this is NaCl. Okay? Let's try another example where you have magnesium with the same guy, chlorine, right? Magnesium, as opposed to sodium, is in group 2 now, and chlorine is in group 7. Verify using a periodic table. And their corresponding charges are going to be, this is going to be +2, and this is going to be -1. So you have magnesium with a 2+ charge. Why does it do that? And chlorine with a negative charge, right? Now, the charge on magnesium is twice as much. You want to have enough chlorines that they balance it out. Think of it that they're on some sort of scale, you know, like that. यहाँ पे 2 अगर प्लस हैं, प्लस सारे यहाँ जाएंगे, माइनस यहाँ पे जाएंगे, right? So यहाँ पे अगर 2 of the pluses हैं, and you can only add chlorines over here, तो कितने chlorines डालने पड़ेंगे to balance this out? Well, -1 एक डाला, it's not balanced, एक और डाला, -1, well, that's a total of -2, balancing out the positive over there. So you need 2 chlorines. So in your head, or the logic is, you're trying to balance it out literally like this. But the easier way about it, how to actually balance it out, is where you try to take the charge and you kind of cross it, right? You take the 2 over there, and there's a 1 over here, you take it over here, and they balance out. So it turns into MagnesiumCl2. And if it can be simplified, if these numbers over here can be simplified, you simplify it. All right, let's do some examples. Leave the chloride, तो हमने कर लिया, sodium chloride, we've done this. Ions वाले अभी उनके ऊपर आते हैं. Or maybe like by the end of it, you're like super sharp and like you don't really need a practice on this. But like do practice. I'm not saying don't practice. ठीक है, potassium chloride देखते हैं. That's one of the easier ones. Potassium chloride में it's potassium, the symbol is K, chlorine is Cl. And if I look at my periodic table, potassium is in group 1 and chlorine is in group 7 or 17. तो वही बात हुई. Chlorine will have a negative charge and potassium will have a positive charge. Now if you remember that weighing scale I mentioned, उनके ऊपर एक तरफ potassium डालूंगा, एक दूसरी तरफ chlorine डालूंगा, तो +1 and -1, it's balanced out. It's the same amount of charge, but opposite charges, they're balancing each other out. ठीक है? It's KCl. This is KCl. Let's look at potassium bromide, which is going to be KNBr. Bromine is right below chlorine, right? So being it's below, that means it's also right in क्या बोलते हैं? Group 7 or 17. So charges negative यहाँ पे +1. तो इसका भी वही हिसाब हो गया. Exactly the same as potassium chloride. Iodide, because it's in the same group, same thing. ठीक है? All right, let's take a look at magnesium chloride. Magnesium chloride is Mg and Cl. अब बराबर नहीं है, because I know. ठीक है? अब कैसे बराबर नहीं है? Magnesium is in group 2, so the charges on it is going to be +2. Chlorine is again group 7, अब तो याद ही हो गया होगा. It's going to be negative, right? तो in that weighing scale जो था हमारा तराजू जो था, right, that thing, I need twice the amount of chlorine over here to balance this. Oops, that's an ugly M. To balance this magnesium out. It has a 2+ charge, so I need 2 chlorines, each with a negative charge to balance this out, right? Let me erase this. All right. So magnesium is, we talked about 2 chlorines, so it's just going to be magnesium MgCl2. You need twice the amount. Why does it do this? I'm gonna start crying now. ठीक है? All right. Another way, a quick short way to do this instead of imagining or drawing the entire tarazu, is that it has a 2+ charge over here and negative charge over here. You just multiply, like you just cross the numbers as the quantities यहाँ पे लेके चले जाते हैं, and if you see, that's exactly what's happening. There's a 1 here, you don't have to write 1, so you don't write it, but the 1 from chlorine goes here and the 2 goes over there. And if they're like in even ratios, then you can simplify them. ठीक है? Let's take a look at magnesium oxide. यहाँ पे you'll see what I mean. Now, magnesium is in, it's the same magnesium. Then oxygen is in group 6 so henceforth its charge is 2 minus. So now they're balanced out. It's just MgO, right? And if you do that cross way of doing it, it's going to be ये power से मैं इस तरह cross करूँगा, right? So it's going to be Mg2O2, but I want to simplify this. Remember, I said simplify. MgO. So one magnesium is happy with one oxygen. That's for magnesium.